Right, so the first one, my first thing, I look at this, got minus 39. I don't know how to write minus 39, but I do know how to write 39. So I'm going to write down 39. Now, it's an 8-bit number. Okay, I'm not going to put the column headings on, but I'm going to make it positive 39. So I'll put a sign bit of 0. I'm not going to have a 64, but I'm going to have a 32. That's going to leave me with 7, so there's going to be no 16 and no 8. Oh. That'll look slick on the video. There we go. Right, so there's no 8, but that leaves me with 7, and 7's the nice number. Right, so I'm not just going to write that. I'm actually going to tell the examiner I know that is plus 39. Now I'm going to perform 2's complement. So remember, that's flip all the bits until I get to the last one, and then leave it as a 1. So I'm going to go flip, 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 flip. That is the last one, so I'll leave it as a 1. So I'm now telling the examiner that that is minus 39, and that's my answer. You can't just put random binary numbers down. You've got to explain to someone what they are. Right, let's have a look at the next one. Minus 2.7. So it's negative, so that's going to cause me problems. I don't know how to write minus 2.7, especially in floating point. So what I'm going to do is I'm going to write down plus 2.7. So when I'm doing my binary stuff, we start with the fixed point. I want to put plus 2. So I need enough columns so that I can make sure I put a positive sign bit. So if I do that many columns, I can put my sign bit in, positive 2 I'm writing. I'm going to write 2, and I need to do 3/4. So I need a half and a quarter. It doesn't matter that I haven't used 6 bits. I'll sort that out when I do the normalization at the end. So that is plus 2.75. So I'm going to indicate to the examiner that I'm not going mad. Yes, I know I've written a positive number. What I'm going to do is I'm going to do 2's complement on it. I don't have to do it now, I could do it later, but I'll do 2's complement on it. So that's flip, and keep flipping until you get to that last one. So I'm going to write flip. That's good because we've got a negative number now. Flip, keep the dot in the same place. Flip, but that's the last one. Okay, so I'm now saying I've written down minus 2.75. But it's not normalised.
Sorry, did you flip the 1?
I don't think you put it in for the top bit on 1. I think it needs to be 0.
Where?
Top, in the
The 1,
first
do you
column.
know
Next to the 1.
first sign bit?
No, 2. So
One.
you've
No,
got
you didn't
the
write it.
1.
I haven't flipped that
two.
one, you mean?
No, in the first line you've got
So that's
2
the
and 1.
value of 1.
Oh, gold, yeah, I've missed a bit. Well spotted. Right, so what would that be?
1.
That'd be a 1, yeah. Good job you spotted that. Yeah, I went completely blind there. It's because I started talking about the fraction before I finished. I'd only put the 2 in over there. Right. Okay, right, so I've written down that. I've got to normalise it. Remember what normalisation does. It just removes all the unnecessary sign bits so that the number starts with the sign and then the detail. So when that's a positive number, we expect the binary point to go 0 binary point 1. When it's a negative number, it's going to be 1 binary point 0. So we can see there is actually only one sign bit. There's no like duplicates. So we need to get the binary point to there. It's currently there, so we're going to annotate this. We're going to go, it's gone 1 place, 2 places. And that's where we're going to put the binary point. So the value, the magnitude of the exponent is now 2. So we can say the exponent is 2, but we need to say whether it's positive or negative 2. Now there's an easy way of doing this. That number was bigger than 1. When we moved that, we've made it less than 1. So it has to be a positive 2 to make it go bigger when we read it back. Okay? So we're saying the exponent is plus 2. Right, I've got everything I need now to finish the question. So I've got to have 6 bits. So the mantissa is going to be 1.01 0, 1. But I need 6 bits. So what do I pad with?
0
0 on the right hand side. What do I pad on the left hand side?
1.
0
The sign bit.
1 1.
Keep it general, sign bit. Right, so that's my mantissa, and then an exponent of plus 2 is 4 bits, so the exponent's going to be that. So for me, I'd make sure that I underline the answer, and I'd say that was the exponent, that was the mantissa. If you start with a number that is bigger than 1, the exponent, when you normalise, will always be positive because it has to get bigger again when you read it back, doesn't it? If I get asked to write 1/4 normalised, then when we do the normalisation bit, we're going to make that number bigger than it is. So the exponent will end up negative. Okay? Right. Annotate. So I've got loads of numbers on there. If there was no annotation, no one would know. They look specifically in the mark schemes for you to say what the exponent values are. You've seen that, so highlight it all. Always highlight it, yeah.
If there's a point, do you have to put it in the mantissa or can you ignore it?
Technically, it doesn't exist. Because when it's held, there isn't another bit that holds the point.
So
It's just in between the first 2 bits.
So when you're writing a value for mantissa, you don't need the point.
No, you don't have to, because it is actually just 1 0 1 0 1 0. Right, okay, the next question, the one that you lot keep messing up. Right, we've got 2 numbers to add together. We're told the format, 5-bit mantissa, 4-bit exponent. Right, my first job, if I add these together, I don't just take all the bits and add them together. That's nonsense. I've got to change the size of these numbers. I've got to, the way that the example used to mark this is that they wanted you to make them the same value of exponent. So like you go, all right, 1's 3, 1's 4. I can see that. So I'm going to identify that. I'm going to say exponent is plus 4. Exponent is plus 3. Now you could equalise them, but it's easier to just unnormalise the 2 numbers, and then it's the same process every time. You're not like going to make a mistake. So I'm going to take this first number, I'm going to write it out. So that's my mantissa. The exponent was plus 4, so I need to make these 4 binary positions bigger. So I'm going to go this way. I'm just going to pad it with a few zeros because I can. Right, and I'm going to do that. So I'm going to go 1, 2, 3, 4. That's where the binary point. And I'm doing the arrow on purpose, so the example would know which way I've moved the point. Right, I don't need to work out what it is. So don't go down this route of working out what the decimal number is. I don't care. They want to just keep it all in binary. So that's my first number. Let's do it with the next one. So again, we've got 0.1100. So that's when I need to put the binary point in, because I'm going to move it. Right. I'm going to just pad with a few zeros. Again, it doesn't matter. I'm just filling up the space. And I'm going to move this 3. So I'm going to go 1, 2, 3. Right. Now I can add these 2 numbers together. I've got to make sure the binary points align. That's all I've got to get right. So I'm going to write down this first number. So I can see it is 0, 1, 0, 1, 1 point. I'm going to keep the 0 zeros. It doesn't really matter. Then when I write the second number down, it's very important that I put the binary point first. Then I'll write the fractional bit. So I've got 3 zeros there. And I've got on the other side, I have got 0, 1, 1, 0. Right. What's important, I wish that would stop screwing up. Right. What's important is that I make these the same size. So on the right hand side, just pad with zeros. On the left hand side, extend the sign bit. So the sign bit is 0, so we're just going to put another 0. I want to do that, and then that'll stop any messing up with the carries and everything. Right, so I'm adding them up, so I'm actually going to do a nice bit of neatness. And now that I've realised that shift is the key that lets me do a straight line, I can do straight line. So I feel like some sort of magician now. Right, and it's just integer arithmetic. We're doing fixed point binary. So it is just integer arithmetic. If you ever get on a computer system that can't do floating point, this is how you can represent fractions. Right, so this is quite trivial. So we got 0, 0, 0, point. Right, and then we got 1 and 0 is 1. 1 and 1 is 0, carry 1. 0, 1 and 1 is 0, carry 1. 1, 0 and 1 is 0, carry 1. 0, 0 and 1 is 1. Okay, what's happened?
You didn't sign it.
I needed to sound extend further, didn't I? Because I've ended up with a negative number and you're going, oh, hang on a minute. Right, so what I should have done was just pad a few more. It doesn't ever hurt to do that. Right, so if I carry that on, so if you ever get that situation, you go, hang on a minute, it's just gone negative. I know they were two positive numbers. When we're dealing with floating point, you haven't got the same problem as integers. With integers, you've got a fixed width. Floating point, because of all this exponent bit, moves around. When the CPU is doing calculations, it doubles the precision. So if I'm doing 32-bit floating point addition, it uses 64-bit numbers. Alright, so the computer knows this is going to be a problem. Right, so I've just sound extended. So I'm going to carry on. I'm going to go, okay, 0 and 0 is 0. Aha, it's positive again. Alright, so don't panic if that happened. Just go, oh, I should have just sound extended a bit more. Okay. Right, that's not my answer. That's me working out. I've now got to normalise it. Right, so we need to go, because it's a positive number, it needs to go sign bit of 0, then the detail of the number. So it's here where I want to put the binary point. So this is going to be a largest exponent. So it's going to be 1, 2, 3, 4, 5. That's where I'm going to put it. So to finish my answer off, remember it was only 5 bits for the mantissa. So this is going to be 0.1000. And then the exponent, and I'm going to write that down. So because I've just demonstrated that, I'm going to say the exponent is plus 5. I've got 4 bits for that. So positive, then I want to put a 4 and a 1. Right. There could be, or there ought to be, a follow-up question to this. What could the follow-up question be?
Something about losing the 1.
Yeah, we've lost a bit of precision. We lost this. Now that would have been, well, difficult to know actually. Well, no, actually, it's worse than that because this is a really poor format. We had the number 17, but we can only represent it as 16. 5 bits isn't much for a mantissa. Not good. You're better off like reducing the amount of space in your exponent and giving it over to your mantissa. Okay, yeah, so we lost precision. So that's my exponent and that's my mantissa. Always label up. You don't know who you're going to get marking this stuff.